has this little script here, kind of like going to serve as a tutorial. I might explain some stuff, might not, but I'll optimize it real quickly. So we'll insert it, toss it into our replicated storage, make a local script here. Oops, not an input action, a local script. We'll call this shader, and all we gotta do here is require that shader, and then we'll just run a single method called init, and we're basically done with this local script. If you do stuff with streaming enabled, then this might actually have some issues. You might have to, I'm not exactly sure how you handle streaming enabled meshes appearing. I don't like streaming enabled. I think it's terrible, so I try to avoid it in most of my games. If you're a mobile developer, you want your game to be played by mobile players, then you probably should have it. Anyways, well, let's go to settings now, and we can change some of these settings real quickly. So first things first, we probably should change this to true. The big thing here is because I'm not going to change everything with our shader here, but our shader will actually call this stuff to be online. Like it'll call a what is the term? It's going to do it's going to do like a server request when it actually what was I say? When it wants to create an edible mesh, because edible meshes, you can't just instance.new edible mesh. It doesn't work that way. So we should just do mesh that we know we own. And if we don't own it, we don't have access to it as an edible mesh. That's just how it works with Roblox. So no player characters can have edible meshes on them. So it has to just be like custom characters like this little fella, or this little fella, this medium fella, and this big fella. Another optimization the developer provides here is a custom frame rate, which this has good intentions, but we're not going to mess with it because so imagine you have a walking, you walk we have every link steps, every 5 steps. The first detail too. This is what you do. When you just constantly walking over like this. And that's how the system works. It's going to say you either walk at the big mountain, or you walk at big at small mountains, or tall at small mountains. So you have your here. Basically, you have low here, and you got this is low yes, so your yes is low, and you got like a higher yes, so we say like it's high, high. And this is bad frame time, you know, you low yes, you want to go back frame time, because the frame time is low in general, or technically high frame time, I like the high frame time, let's hear. So basically, just the original implementation of this kind of sucks. I could showcase it real quickly, but do I want to? Should I? I guess I can. Might as well. Oh wow. But you can kind of see here that our performance is a bit odd. It's not exactly what it was before. And if we were to open up our micro profile, you'll see that it kind of has that like mountains, those little mountains. That's not good. I hope it kind of does. Now, to fix this or optimize it, we can set this back to false because, like I said, I don't want to use this. I don't like this. I'm not going to keep it like that. And we'll actually create a new setting. This will be called meshes per update. Update is better than saying per frame because you could technically still use custom frame rate with this. Should you? I wouldn't, but you can. If optimization is a big thing, let's say your meshes are huge or have a lot of vertices, and you probably do want to do that way maybe. But even then, you really shouldn't have a lot of vertices because that's really going to affect performance. And now, actually, I will show you. I was going to mention it there, but I can show you a bypass for the shadows here if you really want it. You'll probably come across it yourself if you do custom characters, but it's kind of cool. We're going to go on to actually making our little optimization here. And all we gotta do here is go to, I think, run right here. We're gonna add a single big global variable, whatever you call it, which is gonna be called mesh index, and this will be 1. And we're gonna kind of close some of this stuff, get out of our site. We're gonna create a thing called local. We'll call it C. I'm not gonna name stuff. We'll make a number dot main or min. And min is going to get the minimum value. And we're going to have not mesh index, but we're going to have our settings in here. Settings that meshes per update. And the amount of meshes. The idea here is that I will never, if we remember, did I mention what we're doing? Did I mention it? We're only going to update a select amount of meshes per frame or per update. Which is kind of what, I hope that doesn't make sense. Hopefully this kind of told you what I was doing. But that's what we're doing. And obviously, if we only have 2 meshes, then we won't want to update 5 meshes per update because we'd be updating our meshes or an individual mesh more than once per frame, which is not needed. So now we can make a loop here. So for underscore equals 1, C, do. And we'll check if our mesh index is greater than our amount of meshes. And if so, we will set our mesh index to 1, which will basically reset it back to 1. It's like think of it as a cycle, like it's recycling, I don't know, like a circle. And now we'll actually get access to our mesh data. So local mesh data equals meshes, and we'll use that index. And then we'll increment it as well. And now we're kind of done there. And we're actually gonna go down here. We're gonna kind of look at some of the stuff here. We could, sure, we could copy and paste this and throw it up here, but there's some optimizations we can make here as well. And the first one we should make is the is on screen. We should throw this up here. It's gonna make it a little bit worse in the sense of we won't, if we're looking kind of off center of our object, the quote unquote like center position, it will not update these vertices. So here it would not be updating the vertices, which is unfortunate, but it's like a necessary evil. And we'll use the mesh C-frame for this, so mesh position. And we'll check if that's on screen over here, at least within this local space scope, I think is the correct term. I hate programming terms. Wherever I'm at. Anyways, we'll check there instead. And if it's on screen, then we'll actually check. Then we'll go through all the vertices, and it'll do everything. And so we'll just copy and paste that there, and we can remove our old if statement that was within our nested loop. Or yeah. In addition, we can also do a little camera positional check. So we can do like local cam pos equals workspace. But we can use camera, that C-frame the position. And we can do a little positional check as well before our is on screen, because this is more expensive than checking the camera, like the positional change or distance between the two. So we'll use mesh C-frame dot position. I hate how like you think it would just automatically like go to this one. I don't know. Maybe I'm a moron. I feel like it should. Don't know. Magnitude. And we'll just check if it's greater than 100. If it is, then we'll just continue. And that basically means it'll skip to the next one. And now we're kind of done. Obviously, we could actually, did I say obviously? How many times am I saying obviously? I've obviously, not obviously, but we can take note of some cachedness. We can take note of some of these things. So for example, I use camera position here. So I use it there. I don't make a new camera position, make a variable. I don't call for it or anything like that. And look down here. There's another one right here. You can do this. Cool, right? I hope it's cool. And so, really cool. Now we're basically done. All we gotta do is copy our contents right here and throw it up there. And look at that. We are done. So now let's try playing and see how it is. Voila! It's there! Look at that microprofiler. It looks beautiful. Why is it all green? Did I select all of it somehow? It's optimized! It's awesome! Yay! Cool, right? Now we can implement one more thing to showcase how you do shadows. All you need is a humanoid. There you go. Now we have shadows on this thing. So our evil thing here has shadows.